So this universal set S that we've been talking about and using for Venn diagrams, when we start talking about random experiments and probability, S is going to be the collection of all things that could possibly happen as a result of the experiment, all of the possible outcomes. It's called outcome space. And what we will call events are subsets of outcome space. So this is outcome space. And an event okay, so for instance, our experiment could be toss a coin 10 times. So there's an experiment. In a row. Okay, so what would outcome space consist of then? What can happen when you toss a coin 10 times? So we could actually think about this a bunch of different ways. There are a bunch of different ways of sort of turning this into a piece of math. But if we really care about whether you get heads or tails in each toss, then an outcome, what can happen as a result, is a sequence of heads and tails of length 10 in all. Okay, so one thing that could happen is you could get heads, heads, heads. Is that 10? Okay, so that is one outcome. It is an event. Okay, it's a simple outcome. It's one thing that could possibly happen. We could also get all tails, or we could get heads, tails. One, two, three, four, five, six, seven, 8, 9, 10. Should probably end with tails if it started with heads and it's even. Yes? Okay. All right. So an event is a subset of outcome space. These are particular outcomes. What is an example of an event in this case? An event might be the event that you get 2 heads in all. Okay. So one example of an event might be, we'll call this A, is the event that you get 2 heads in all. Okay, so what subset of outcome space does that correspond to? If outcome space is all sequences of 10 heads and tails, sequences of length 10 comprised of heads and tails, what does A actually look like? We've written it in words, but how would we write it in terms of these outcomes?
Head and 8 tails? Is that what you're saying?
Okay, so the subset of outcome space that corresponds to getting 2 heads and 8 tails, right? It has a bunch of members. There are a bunch of different outcomes that all correspond to that event occurring. One outcome that corresponds to that event occurring would be heads, heads, and then 8 tails. Okay, another outcome would be heads, eight tails, and a head, right? How many of these elementary outcomes are in this event? You got 10 places. 2 of them need to get heads in them. There's 10 choose 2 ways of picking which 2 of the 10 places get heads. So there are, in all, if we wrote all of these down, there would be 10 choose 2 sequences of heads and tails that have, sequences of 10 heads and tails that have exactly 2 heads. So in this event, this subset of outcome space, there are 10 choose 2 elementary outcomes, sequences like this. Does this work for people? Okay, when you think about an experiment and asking whether a particular event occurred or not, one thing that I find useful heuristically is if you think about the outcome space as being a dartboard, and you throw a dart at the dartboard. And if the dart sticks in the event, then the event occurred. All right? So I toss 10 coins, and if what happened was I got one of the sequences that contains 2 heads and 8 tails, then the dart stuck in this event, which is exactly 2 heads happening. If the dart stuck outside there, that event didn't occur. Okay, so lots and lots of different events. So what about the event that you get at least 1 head? How would that be represented here? Would it be would it contain this? Would it be a subset of that? Which is more restrictive, getting exactly 2 heads or getting at least 1 head?
No, getting exactly 2.
Okay.
Getting exactly 2.
Getting exactly 2 is one of the ways you can get at least 1, right? You could get 1, you get 2, you get 3, you could get 7, you could get 10, right? So getting at least 1 is less of a restriction than getting exactly 2. Getting exactly 2 satisfies the restriction of getting at least 1. So the event of getting at least 1 is going to contain this.
It's like the complement of 10 tails, right?
Yeah, it's everything but 10 tails. Yeah. Okay? So now, if I throw the dart and the dart sticks here, that means that I got at least 1 head, but I didn't get exactly 2 heads. Okay, so you think about what events occurred. If the dart stuck here, this less restrictive event occurred, but the more restrictive event didn't occur. If the dart sticks here, both of the events occurred. The dart stuck in both of them, because getting exactly 2 heads implies that you got at least 1 head. When you think about these things, what does it mean for one event to imply another? In this pictorial representation, it means that if the first event occurred, the second must also have occurred. All right? So in this representation, there is no way for the dart to stick in the event that you get exactly 2 heads without it also sticking in the event that you got at least 1 head. Right? It's a subset. So one event implies another event if it's a subset of the second event. People often get this backwards, right? So okay, does A imply B or does B imply A?
B implies A.
Yeah, B implies A. There's no way for the dart to stick in B without it also sticking in A. Okay? What about here? Does A imply B? Does B imply A? Neither one, right? Because the dart can stick in one without sticking in the other. It can stick in both at the same time, but it doesn't have to.